Lesson 55 is Maclaurin polynomials. I was writing it on the board yesterday and we were just ready before we were getting ready to leave, and Logan and Natalie were both trying to pronounce it. It was quite funny listening to them. You know, Maclaurin polynomials.
How are they pronounced?
I don't know. It was more Natalie, who doesn't even know the word polynomial. You know, Logan barely knows the word polynomial, so, you know, Natalie's trying to pronounce it. It was quite funny. I don't remember how she was pronouncing it, but what can I say? Not right.
To say the least.
She tried. She gave it a good try. It wasn't bad, I mean. Okay, so Maclaurin polynomial. What we're looking at is being able to take a function and put it in a polynomial form. Okay, there are certain things that we can do with polynomials easier or whatnot from other things. So Maclaurin polynomials be able to put it in a polynomial form. I don't know that we really get into Maclaurin series, or if we do, I'm forgetting it right now. I think we just mainly look at the polynomials here. Now, okay, so you've got this form up here. General form of, and this is really just general form of any polynomial. Okay, f of x equals a of 0 plus a of 1x plus a of 2x squared plus a of 3x to the third plus how many times you need to do it, right? Until you get to your highest power, a of n x to the n. Now, realize your a's are your constants. It's like a of 0 is just a constant. This is a constant times x to the first, x to the second, x to the third, however high you either are told to go or can go depending on the problem. Now, notice the next line. It defines a of o, a of 1, a of 2, a of 3. Okay? In order to find a of 0, so this is a constant. In order to find this constant, you find f of 0 and divide by 0 factorial. In order to find a of 1, you find f prime of 0, so the first derivative evaluated 0 divided by 1 factorial. In order to find a of 2, you find the second derivative evaluated 0 divided by 2 factorial. A of 3 is the third derivative at 0 divided by 3 factorial, so on and so forth. Yes?
How is it a 0 factorial? It's like everything goes down to always down to 1. The 0 goes
0 factorial is defined as 1. I think it's just kind of a special case that 0 factorial is 1.
Oh.
And your calculator would tell you that too, but, yep. Okay, so on this first one, okay, this is kind of our testing here, our trial here. We're being asked to find the Maclaurin polynomial for f of x equals 2x squared plus 3x minus 4. Notice, you guys know what I mean when I say polynomial? I guess maybe I should review that terminology. You've been talking about polynomials since algebra before. But like polynomial is when you have various terms that are added or subtracted. And I know, pre-cal, polynomial has to have a positive exponent. It can't be a fraction exponent. So it's just your basics, like 2x squared plus 3x minus 4. That's a polynomial. Now, so to write the Maclaurin polynomial here, we're practicing using this setup. Okay. Notice how high does this one go? This one goes to a power or degree of 2. And these other two down here, you'll notice they'll tell us what degree we need to go to. Okay. So when we do Maclaurin polynomial, you will usually see, nope, they don't have it up there. We use p of x usually, just represents polynomial. And without even doing anything in the problem, since we're going up to x to the second, right? Okay, well, a of 0. How do we do a of 0? As f of 0 over 0 factorial. I'll go back and fill stuff in here in a moment. Plus, okay, a of 1 times x. How do we do a of 1? First derivative at 0 divided by 1 factorial, and then it's times x. So that fraction I just wrote is your coefficient. And then to get to your second degree, remember it's a of 2x squared. So a of 2 is the second derivative evaluated at 0 divided by 2 factorial, and then this is x to the second. If we were told to go to like degree 4, we'd keep going up through x to the 4th. Or when we're told to go to degree 6, we'll keep going up through x to the 6th. Okay? Now, so f of 0 divided by 0 factorial. What is f of 0? No. Why negative 4? Yeah. F of 0 means you're taking the function you were given, right? And plugging 0 in. So 2 times 0 squared plus 3 times 0 minus 4. So 0 plus 0 minus 4. So that's negative 4 divided by 0 factorial. 0 factorial by definition is 1. Now, and this is a constant, so there's no x or anything after it. That's your first term. I'll clean it up in a moment. I guess I think you guys are okay. You guys know what I mean when I say factorial, which is the exclamation point? What's an exclamation point do in math? Yeah, you're multiplying all the way down to 1, right? Now 0 factorial, as I said, special definition. Okay. Now, what about f prime of 0? How do I find f prime of 0? Okay, so you're going to have to find the derivative. What is the derivative? Oops, of 2x squared plus 3x minus 4? 4x plus 3. So what is f prime of 0? When you plug in 0, 4 times 0 is 0 plus 3, so it's 3. Divided by 1 factorial. What is 1 factorial? It's also 1 because it's just, you multiply everything down to 1, so it's just 1. Then times x. That'll be your coefficient on the x term. Plus. Okay, do the same thing for the x squared term. F double prime of 0. So we have to find the second derivative. What is the second derivative? What's the derivative of 4x plus 3? 4. So what is that when you plug 0 in? It stays the same, and it's 4. Over 2 factorial. What's 2 factorial? Because 2 times 1, which is 2, times x squared. Okay, clean it up. Negative 4 over 1, negative 4 plus 3x plus 2x squared. I was just going to ask, did you catch it? What's my answer? What I started with. I mean, could I rearrange the order? Okay.
Yeah.
Now, as I said, the idea, no. This one works out this way. You're like, that was really pointless. Okay. This one worked out this way because we started with a polynomial. Okay? And so it should end as the same polynomial. Well, as you look at the next one is e to the x. E to the x is not a polynomial. Okay, because a polynomial has to have a base of x, so x to some power. And so that's not a polynomial. So what's going to happen, I mean, your original and your ending are equivalent. What's going to happen is we're going to get an equivalent polynomial for e to the x. Okay? So, ready to try this one? Now, it says find the Maclaurin polynomial of degree 4 for e to the x. So I'm actually going to start off writing pretty much the same line I started off writing last time, except how high do I have to go this time? To the 4. As you get better at these, you may skip some of these steps. So p of x equals, to find the constant, it's f of 0 divided by 0 factorial. To find the x of the first term, it's f prime of 0 divided by 1 factorial times x to the first. Now we change everything to 2's on the next one, right? F double prime of 0 divided by 2 factorial times x to the second. So next one. Do I need to slow down so you guys can get a step ahead of me, or you're okay? So f triple prime of 0, 3 factorial, x to the third, and fourth derivative at 0, 4 factorial, x to the fourth. What?
I said we're really getting deep in this one. There's 4 of them.
F of 0. Just wait when we have to do 6 in the next one then. Just saying. Okay. F of 0. What do we get when we plug 0 into the original function? E raised to 0. Anything raised to 0 is 1. So it's 1 over 0 oh, what did I write here? Well, shoot. Okay, I'm going to write it as e to the 0 for a moment. I'll come back and clean up in the next step. If you want to go ahead and write 1, you can. So I'm going to write it as e to the 0 over 1 plus f prime of 0. What's the first derivative of e to the x?
Is it just E?
E to the x. The derivative of e to the x is e to the x. So when you plug it in, again, it's going to be e to the 0 over 1 factorial. What's 1 factorial? 1 times x. Second derivative. What's the second derivative? What's the derivative of e to the x? E to the x. So when you plug in 0, it's going to be e to the 0. 2 factorial? 2, because 2 times 1 is 2. Plus, what's the third derivative? E to the x. You plug 0 in, it's e to the 0. What about 3 factorial? 3 times 2 times 1, so 6. X to the third. Plus, you getting the deal here? Fourth derivative of e to the x? E to the x. So e to the 0.
27.
4 factorial. 24. Because 3 times 2 times 1 was 6. Times a 4 is 24. X to the fourth. What are all those e to the 0's becoming? 1's. So there's a couple different ways you could write this. If we just do the cleanup, it's 1 plus 1x plus 1/2 x squared plus 1/6 x to the third plus 1/24 x to the fourth. Now, okay, what do I have boxed here? Well, and look at it, guys. Do we have a polynomial now? It's multiple x terms added, right? So this is a polynomial. We have written a polynomial. And when I was looking at my notes, I'm trying to remember, I'm guessing I have this box because this is what the answer key does. Something like the 1 and the x, they leave it as those because they cleaned up to that. Something like this. It's x squared. You could write it as a fraction, x squared over 2. But they also tend to sometimes leave the factorials. 2 came from what? 2 factorial. So you might see it in the answer key where it's x squared over 2 factorial. Plus, okay, we could say x cubed over 6, but where did that 6 come from? 3 factorial. So x to the third over 3 factorial. And then the last one is x to the fourth over 4 factorial. This is what I have boxed in my notes. I'm trying to remember what the answer key does with these. I can't remember. I mean, it's one of those things, again, be familiar with your equivalent forms there. There's 55 starts. Okay. Yeah, they pretty much, it looks like they kind of put it in this form, so. Okay. One more to try? Okay, example 3. Find the Maclaurin polynomial of degree 6 where f of x equals cosine x. Now, do you let me take a lead? Well, I was going to, do you guys still want me to write out that first line the same? I didn't necessarily in the past, but, I mean, I haven't in the past, but I can, or at least I did last year for whatever reason. You're going up to degree 6, right? Which means I'm going to have to know how many derivatives. 6 derivatives. So what I actually have done is, when I probably took a leaf in the book, is I'm going to set up a chart, and let's go ahead and find our derivatives first. I'll explain. So I'm going to have 3 columns. There's going to be the n column, fn of x, and fn of 0. And this is going to make it easier. Like I didn't write out that big whole first step, and I think this will make it easier to not write out that big whole first step. Okay, so n represents like what derivative one. So I'm going to have 0 being the original, and then up through 6. No, just room to write across. Because this is where I'm going to go ahead and find my original and then all the derivatives and go ahead and do the math that behind that. So what's my original function? My original function is cosine x. So in this top row, when n is 0, I'm starting with the original, which is cosine x. This column over here is, what do I get when I plug 0 in to that function right there? So what is the cosine of 0? And cosine of 0 is 1. You guys have a way you find your cosine signs of things like 0? I have my way out to the same here, so you guys use the unit circle? Yeah. Okay, you might use it, but yeah. So if you talk unit circle, right? This is 1, 0. This is 0, 1. Negative 1, 0. 0, negative 1, yes? But keep in mind, what are we always going to be plugging in? 0. So this right here is what you need to know. So now when n is 1, that means f prime of x. So what is the first derivative of cosine x? So what's the derivative of cosine? Negative sine x. Now over in this column, plug in 0. What is the sine of 0? 0. And what's the negative of that? So 0. I have to ask, okay? Because you give me that crazy look like you really just said that. Okay. Now we're doing the second derivative, which just means I'm doing the derivative of negative sine x. I like to forget my negative for a moment. What's the derivative of sine? Cosine. So what's the derivative of negative sine? Negative cosine x. So what is negative cosine of 0? Well, cosine of 0 was 1. The opposite of that? Negative 1. You see what I'm doing this chart? Let's keep it all together once. We're not keep going back. Where was I last at? What's that derivative? Okay, third derivative. What's the derivative of negative cosine x? Because the derivative of cosine is negative sine, and the opposite of that is positive sine. What's sine of 0? 0. Derivative of sine? Cosine. Cosine of 0? 1. Derivative of cosine? Negative sine. Negative sine of 0? 0. Derivative of negative sine? And negative cosine of 0? 1. They go, she used the word repeating. Technically it's a cycle of 4, I think. But repeating the pattern, yeah. Just making sure everyone got that. Okay. And so it'd be pretty easy to keep going farther repeating too. Okay, here we go. P of x equals. So on top, it's always what you get when you plug in 0, right? And then the bottom is the factorial. So you can use your chart right here. Okay, when n is 0, we have what's on top is going to be this. 1 over, what goes on bottom of the first one? 0 factorial. And yes, I know technically I'm writing that down at the moment. Next one. What goes on top? 0 over 1 factorial times x. Plus. What goes on top next time? Negative 1 over 2 factorial x squared. What goes on top of the next one? 0 over 3 factorial x to the third. plus, this is on my 4 line. What do we have? 1 over 4 factorial x to the 4th plus 0 over 5 factorial x to the 5th plus negative 1, 6 factorial x to the 6th. Now, you definitely should clean this up. Okay. Get rid of half these terms. Put 0 on top of the fraction, make the fraction 0. And 0 times x cubed, and 0 times x to the 5th. Those are gone. And I'll tell you, whenever you're doing the Maclaurin series for a cosine or a sine, you're always going to end up dropping every other term. Sometimes it'll be the odds, sometimes it'll be the evens. Okay? Just don't be able to show me the work behind it, though. Okay. 1 divided by 0 factorial. 1. We're dropping the x term. The x squared term is technically going to be a minus. And we write it like I did earlier. It's x squared over 2 or 2 factorial. Dropping the x cubed. My x to the 4th is now plus. And this is x to the 4th over 4 factorial. Dropping x to the 5th. And what do you notice about the x to the 6th? Minus x to the 6th over 6 factorial. Now they asked for degree 6, so we stop there. Do you see the pattern if you kept going? It's the even powers, and the signs alternate. So you can keep writing this infinitely. Okay? In homework, I do not believe they necessarily tell you what degree to go to. If they don't tell you a degree to go to, I want to say maybe 4 is a good number. You can do 6. I mean,